Alright, so our last video cut off when I was checking the third interval for our second chapter 4 review problem. And that interval is x is greater than 5. So I again just pick a number that works with that interval, and I just chose the closest whole number that was the smallest whole number that fits into that interval, which is 6. Just to make my numbers easier, and I recommend that you do the same. So the square root of 6 is 36, times 2 is 72. Then negative 11 times 6 equals negative 66. Carry down the plus 5, and when you work out all that math, it equals to 11, and 11 is of course greater than 5, so that interval checks out. So your final answer is x is less than 1/2 or x is greater than 5, and it's an or because no number could be less than 1/2 and also greater than 5, and making sure you get that interval right and the or really will help if you have to graph the equation, or I mean not the equation, inequality, especially for shading and where to draw it. Alright, so our last chapter 4 review problem is dealing with complex numbers and I, and so the problem is 6 minus 4i times 1 minus 3i, and when you see these two sets of parentheses with 4 terms, you always want to be able to immediately recognize that you need to FOIL. So first outside, inside, last. After multiplying 6 times 1, you get 6. Negative 4i times, 6 times negative 3i equals negative 18i. Negative 4i times 1, negative 4i. And then negative 4i times negative 3i, positive 12i squared. So then you're just going to want to add like terms, which is the negative 18i and the negative 4i, to get 22i. And then you see this 12i squared, and something special about the I squared is you can, if you ever see that, you can immediately substitute negative 1, because I squared equals the radical of the square root of negative 1, and so if you have two of them, it's negative 1, the square root of negative 1 times the square root of negative 1, and when you do this multiplication, the radical signs cancel out, leaving you with just 1, negative 1. And so you can plug that right in for I squared, giving you a negative 12. So negative 12 minus 6 equals negative 6. And then, so your final solution should be negative 6 minus 22i. All right. So now we're going to move on to our Chapter 5 review. And the first problem of our Chapter 5 review deals with the fundamental theorem of algebra. And it is, the directions are asking us to write a polynomial function with a leading coefficient of 1 and zeros at negative 1, 6, and 3i. So you'll notice that it just gave me 3 zeros, but I immediately added this negative 3i because anytime you're given a 0 with a radical or an imaginary number, you can immediately include the opposite also as a 0. So they give me 3i, so then I knew that negative 3i was also a 0. It would be the same if you're given a radical 2. You would immediately also include negative radical 2 as a 0 as well. So then you're going to take these now 4 zeros and plug them in. And so you're going to want to flip the sign before plugging them in. So I start with negative 1, but when I plug it in, it's going to be x plus 1, flipping the sign. I have positive 6, but I'm going to flip the sign, so it's x minus 6, and then multiplied by x minus 3, x plus 3. Alright, so now you see these two binomials with these 4 terms, and you're just going to factor first the x plus 1 by the x minus 6, and then the x minus 3i by the x plus 3i. So when you FOIL these two sets of parentheses, you should end up with x squared plus x minus 6i minus 6. And when you FOIL the x minus 3i and the x plus I, you should end up with x squared minus 3ix plus 3ix minus 9i squared. Alright, so you're just going to want to add like terms from this set, which is the x minus the 6x, so you're left with 5x. And then you're going to want to cancel out the negative and positive 3ix, because if you added a positive 3ix plus negative 3ix, you're given 0. And then you see this I squared, and from the last problem we just did during the chapter 4 review, you know that you can immediately substitute -1 in whenever you see an I squared, because when you multiply the radical of -1 times the radical of -1, you just end up with -1. So when you multiply -1 by -9, you get a positive 9. So you get, so the next step leaves you with x squared minus 5x minus 6 times x squared plus 9. So now you're just going to want to distribute the x squared to all three terms, and then distribute the 9 to all three terms. So when you distribute the x squared, you're left with x to the 4th minus 5x to the 3rd times -6 leaves you with -6x squared. And when you distribute the 9, you get 9x squared, -45x, and -54. So your final answer after combining these two like terms is x to the 4th minus 5x cubed plus 3x squared minus 45x minus 54. Alright, our second review problem from chapter 5 is dealing with the difference of two cubes, and our starting problem is 64x cubed minus 8. And so something different about this equation from other differences of cubes or sums of cubes is that we have this large coefficient right out here, and what we want to immediately do is factor. So we have 8, and 8 goes into both 64 and itself 8, and so when you pull an 8 out, you're left with 2x cubed minus 1. So now with this, the numbers inside of the parentheses, you're going to want to plug them into the equation for the difference of two cubes, which I've written right over here. It's x minus y times x squared plus x times y plus y squared. Alright, so when you plug that in, you're going to bring down the 8. You don't want to forget that. And you're left with 2x plus 1. And it's a plus 1 because you're plugging in a -1 into an equation that starts with a negative. Negative times a plus with a negative is a positive. So then, when you plug the rest of it into the second part of the equation, 2 squared is 4, so you get 4x squared plus 2x times 1, and then 1 squared. And then when you simplify that and you multiply these two terms and find the 1 times 1, your final answer should be 8 times 2x plus 1, and that is all multiplied, open parentheses, 4x squared plus 2x plus 1, close parentheses. And that is your final answer. So our last chapter 5 review problem is dealing with synthetic division. And so our starting problem is 2x cubed minus 11x squared plus 13x minus 44, all divided by x minus 5. So the first thing you're going to want to do is find out what number you're actually going to divide by. And you do this by just flipping the sign of whatever is being added or subtracted from the x. So in this case, it's being just subtracted, so -5 turns into +5, and that is what we will be dividing by. If it said x plus 5, we would be dividing by -5. Alright, so now you're going to bring down the constant terms, which is from this equation, so 2, -11, 13, and -44. Our first step is going to just be to bring down the 2 straight down, and then you're going to take that 2, multiply it by the 5, gets you 10. -11 plus 10 leaves you with -1. -1 times 5 equals -5. 13 plus -5 leaves you with +8. +8 times 5 equals +40. -44 plus 40 leaves you with -4. And then when you're given those answers, you're just going to want to add the x's from this equation, and you're going to want to start with a degree less than the degree from the original problem. So 2x cubed minus 1x plus 8, and you have a remainder of -4. So that is all for the chapter 5 review. We're now going to move on to the chapter 6. So the first problem of the Chapter 6 review, we're going to be graphing. So we're going to be graphing y equals the cubic root of x minus 4 minus 5. So what you're going to want to start off doing is graphing the parent function of the cubic root of x. And so the cubic root of x, you can plug into your calculator, but it has the points 0, 0, negative 1, and positive 1. And then you're just going to look at your equation to see how far you move it right or left or up or down. So the number attached to the x determines how much you're going to shift it to the right or left or horizontally. And you're always going to want to make sure to flip the sign when it's attached to the x. So it's x minus 4, but really it's going to turn into a positive 4, which means that we're going to be shifting each point of the parent function to the right for 4 points. Alright, and then this negative 5 out here stays negative, which means we're going to be shifting every point from the parent function down by 5. So that is what I did. I took this first point. Sometimes it might be better to get more points for graphs, especially if they're a little bit more complicated equations, but you just move it. I just shifted it 4 to the right, 5 down, second point, 4 to the right, 5 down, and 4 to the right, 5 down, and then I connected them. And you can always use your graphing calculator or Desmos to make sure that you're on the right track and the trend is going the right way. Alright, so our second Chapter 6 review is dealing with, that's Chapter 7. Our second Chapter 6 review problem is 3x to the 3 over 4 equals 24. So our first step for this equation is going to be getting the x by itself by dividing both sides by 3, which leaves you with x to 3 to the 4th equals 8 because 24 divided by 3 is 8. Now to get rid of this exponent, to get x totally by itself, you're going to want to multiply each side by the degree 4/3, because that is the reciprocal of the degree already there, and so those cancel out, leaving you with just x on the left-hand side, and the cubic root of 8 to the 4th, because the denominator becomes the radical, and the numerator becomes what the degree of the term. So the cubic root of 8 is 2, and 2 to the 4th is 16, so your final answer is x to the 16th, and you can check that by just plugging 16 into your original equation, which when you plug that into your calculator comes out to 24, and 24 equals 24, so it works out. The last Chapter 6 review problem is the square root of 18x to the 5th times y to the 4th, 49x to the 1st times z to the 5th. So I like to leave this 2 out here. It's always there if no other number is outside of the radical, but it helps me remember what I'm dividing into, the equation. And so your first step is just going to be to break down every term into something that's divisible by 2 or contains a perfect square. So 49 is already divisible, can be broken down to 7 times 7, so we can leave that. But 18 isn't a perfect cube, but it has one in it, so 9. So you're going to want to break that down into 9 times 2, and then you can, since there's an x on top and bottom, you can divide those, which means that you're just going to subtract the exponent, so x to the 5th, 5 minus 1, 4th, so just x to the 4th in the numerator. You can leave y to the 4th alone because that's divisible by 2, and then you have z to the 5th, which you can break down into z to the 4th, and then leave a z, which you're not going to be able to do anything with, but you can do something with the z to the 4th now. Alright, so now you are just going to want to find the square root of all those terms, and once you do that, you're left with 3x squared times y squared, and you can't do anything with that 2, so you're just going to leave that 2 in the radical. And then in the denominator, you're left with 7z squared and the radical of z. However, you can't leave the radical of z or any radicals in the denominator. So you're going to have to multiply the equation by z, the square root of z over the square root of z, and multiplying two square roots with the same base gets rid of the radical signs but leaves one z, and you can add this radical z in with this radical 2, so your numerator should now be 3x squared times y squared radical 2z, and then the denominator 7, and you get the z to the third because you're left with 1z, and when you multiply two numbers with the same base, you add their exponents, so this was z to the first times z to the second, so 2 plus 1 is 3, so you're left with z cubed, and this is your final answer.